information is on the figure. So we need to integrate z squared dz. Let's start with a. Okay. So let me show you how this works, and then maybe you can try the second. So in part A, yeah, we're integrating z squared dz along the closed integral. So what we could do is we can go over 4 paths. So we can divide this into 4 paths. Yeah, we could go from -1 to 1. So this is path number 1 here. Okay. And then we can go from, this is 1 plus I, so it's just like any other line integral. We can go over 1 plus I, so this is path number 2. And then we could go from 1 plus I to -1 plus I, so this is path number 3. And then finally we can go back down to -1. So this is path number 4. And then all you have to do is integrate each one of these. So then, so z squared dz, you're going to have to take the closed integral. So you're starting at, let's say, 0. So we're starting this at, she just says integrate. No tricks there, yeah? And we can go from let's start with path number 1. Okay, so this is over the closed integral. Okay, let's start with path number 1. So path number 1. Okay, what's z? Well, this is a complex function. Remember, we're dealing with complex functions. Z is x plus iy. So then we can find dz from here. So what's dz? X becomes dx, and y becomes dy. So this is I dy. Okay. Now on path number 1. What's dx? We don't know. It's dx because x is changing. You're going horizontally. This is path number 1. It's along the x-axis. So x is changing. Therefore, this guy is present. Yeah. Now, is dy there? No, because on that path y is 0, which makes dy 0. So then if you plug these in here, so what's dz? So the outcome is dz is just I dy. I'm sorry, it's dx. The second term vanishes. Yeah? So now if I integrate over path 1, then I would find z squared dz on path number 1. Well, so I'm going to go from -1 to 1. That's path number 1. Yeah? -1 to 1, z squared dz, and z is just x plus iy, right? And we said that y is 0. Let's just write it and then we'll put in. And then dz is dx plus I dy, and we said that this guy is 0 and this guy is 0. So what do we have? What are we left with? This is path number 1. We're left with -1 to 1. X squared dx, yeah? And what's that? X cubed over 3 from -1 to 1. So that gets you 1/3 minus 1/3. So we get 2/3 for this. So path number 1 is 2/3. Okay, let's go on path number 2. So now path number 2. Now, on path number 2, we are going vertically up. Yeah? Vertically up, so that means we're not changing x, so dx is 0. Yeah? And we are at x equals 1 because we are here on path number 2. So that means x is 1. It's very similar to the line integrals that we did in vector calculus. So x is 1 and dx is 0, so then dz becomes, so we said that z is x plus iy, right? Y is varying, of course. X is 1, so this becomes 1 plus iy. 1 plus iy. And dz will be dx. Well, there's no dx, yeah? So 0 because it's fixed. I dy. And now we can just plug it on. So we're going to integrate on path number 2, z squared dz. Hello? Yeah. Okay, so z squared will be 1. Let's do that. So 1 plus iy squared. Yeah. And then dz is I dy. And we are integrating. This is a dy integral. Where is y going? Y, if you look in the figure, y is going from 0 to 1. Yeah? Because y is varying from 0 to 1. Remember, I is the complex part of this. Yeah, so this is varying from 0 to 1. Okay, and then if we just carry over the integration, so this will be 1 plus 2iy plus I squared becomes minus 1, so this is minus y squared. And this whole thing is multiplied by I dy from 0 to 1. Let's simplify this further. So this becomes, we can pull the I out, yeah, and then integrate. We could pull the I out and integrate. Let me get back to it here. Okay, this is from 0 to 1 dy. So we get I, we start here. I will get y minus y cubed over 3. Right, that's the y squared term. Oh, I forgot the middle term. The middle term is what's that? 2iy. So this becomes iy squared plus y3 over 3 from 0 to 1. So plug in the 1, you get 1 minus I plus 1/3. Oh wait, this is minus y squared because I squared is minus 1. So this is minus here. This is plus, yeah. So this becomes 1 plus I minus 1/3. And then minus, the 0 will just make them 0 because they all have y's in them. And so I'm going to get 1 minus 1/3, so the final answer here will be 2/3 plus I. Oh wait, there's an I outside too. So this will be minus 1. When I multiply I times I, that's minus 1 plus 2/3 I. Yeah, plus 2/3. So this is the second, yeah. And now if I go on number 3, on number 3. So that's path number 3. So now we're going along horizontally. Again, horizontally, that means right? That means dy is not changing, so dy is 0. And we know that y is 1 horizontally because we're at y equals 1. Yeah. Remember, the dy is just the real part of the function. That's why I didn't take the I with it, because it's sorry, the imaginary part. It's x plus iy. Yeah. Oh man, this part keeps on shutting down. So annoying. Okay, so we were on path number 3, right? So on path number 3, let's see, we said that the y is the imaginary part, that's why it's 1, I was saying, and we're not moving in the y. We're not moving in the y, so y equals 1. Dx is changing because now we are going back horizontally. Yeah. So we're gonna get dz. Stay on the shape. Dz. So we said that x or z equals x plus iy, and so x is changing, and x is what's x here? 1. No, x varies, and y is 1. Yeah, so this becomes x plus iy, or 1i, so x plus I. So dz, there's no dy, so it's just going to be dz will just be dx. And then, so if I integrate on path number 3, z squared dz, I will get z is x plus I square, and then we said that dy is dx, dz is dx, and where am I going? I'm going from, let's see, now we're going backwards, so we're going from 1 to minus 1, because we're going to the left. So if we FOIL this, what do we get here? 1 to minus 1 x squared plus 2ix minus 1, because I squared is minus 1. That's dx, and now we can integrate piece by piece. So x cubed over 3 plus ix squared minus x, and we're going from 1 to minus 1. Plug in the 1, we get or minus 1 first, upper bound first, so minus 1/3 1 plus I minus minus 1, so this becomes plus 1. That's the upper bound minus the lower bound, so the lower bound is 1, so that's 1/3, just straightforward algebra here. Plus I minus 1. Okay, let's simplify this. So we have minus 1/3 minus 1/3, that's minus 2/3. We have 1 plus 1, that's 2, and we have I, so the i's go away, and I actually get a real answer on path number 3. So the answer is what? 6 minus 2, 4/3. So 4/3. So path number 3 is 4/3. Yeah. Now we'll go over path number 4. So let's see, path number 4. Now on 4, I'm going vertically down, so that means I have a change in y. This exists. There's no change in x. Dx is 0, and on that path, what's x? X is minus 1, correct? Because that's where we are now. And so z is equal to x plus iy, right? X is minus 1, iy is just iy because, you know, y is varying. We don't know what y is. And so dz will be just x does not vary. There's no dx, no change in x, so this will just be I dy. And then if we just plug it in, so now we will do z squared dz on path number 4. It's really annoying. Not sure why it's not liking it. Okay. Yeah, so dz is just I dy. So now I'm gonna integrate on path number 4, z squared dz. So we said that z is minus 1 plus iy squared times dz, which is I dy. Okay, so we get 1 minus 2 iy plus I squared y squared. I squared is minus 1, so that's minus y squared dy, yeah, or times I dy. Okay, so now, oh, and by the way, the bounds, we are going from where are we? We are on path number 4. Let's go to the figure. Where are we on the y? We're going from 1 in the y, because that's the imaginary part of minus 1 plus I, down to 0. So 1 to 0. 1 to 0. 1 to 0. Okay, so what does this become? Let's integrate y minus iy squared minus 1/3 y cubed from 1 to 0, and there's an I outside. So on the 0 count, everything is 0 because they all have I, minus I. On the 1 count, we get 1 minus I minus 1/3. And so we get minus I plus I squared, which is minus 1, plus 1/3 I. And so we get, right? We get 1/3. 1/3 minus I, that's what, minus 2/3 I. So minus 1 minus 2/3 I. This is path number 4. Okay, so what would the entire thing be? We just add them up. So so the entire integral, so now let's conclude. The whole thing, z squared dz, you know, from, if you want to call it, from 0 to 1 plus I, because that's what the bounds are, yeah. Let's add them up. What do you expect the answer will be? Well, it will be 0. Because I mean, this question, they didn't want you to use that theorem, but there's a theorem in the section that says you are required to do direct integration in order to figure out what the answer is. But this is 0 because there's a theorem that says if the function is analytic, then the integral of a closed path has to be 0. That's called Cauchy's theorem, right? And this is an analytic function, so that means it has to be 0. Well, let's see if we get 0. So path number one was, I mean, if we didn't get 0, then something is wrong. On path number one, the answer was 2/3, then minus 1 plus 2/3 I. So 2/3 minus 1 plus 2/3 I. And then the third integral was 4/3, so plus 4/3. And the last one is up here, minus 1 minus 2/3 I. So let's see, those guys go away. Minus 1 and minus 1 is minus 2. 2/3 minus 2 is what? It's minus 4/3, right? So these guys cross out. And indeed, the answer is 0. As expected. That's from Cauchy's theorem. Since the function is analytic, the integral had to be 0. Questions so far? You want to attempt B?
What does analytic mean again?
Analytic is sort of like continuous in single variable calculus. It just means that you could technically draw any circle with radius r inside a region, and even if you touch a singularity on the region, as long as it's defined on that region, right? Then it's called analytic.